Hi, everybody. This is our homework one solutions. I was going to write these up and scan them in, but I decided there were a lot of things I wanted to say. Um, so I'm going to do it as a video. Hopefully that's more helpful than just looking at some answers. So problem 3.9, the first problem, really simple. The only thing you need to know here is that if you add vectors, you add them component-wise. So when it asks you to find a plus b, add the components, the I components of a and b, add the j components of a and b, add the k components of a and b, and they'll give you the a plus b components. Similarly, subtracting, same thing, except you would subtract the components from each other, a minus b. They gave you the equation for this and asked you to find c. So you can move a minus b to the other side of the equation, you get b minus a. I'm going to just do the same thing. That's all simple stuff. I'm pretty sure you all can do that pretty easily. So moving on, problem 315. This problem has a lot of weird, or at least one tricky thing that we've got to find. What they ask you to do here is they give you a vector A, and they give you the magnitude is 13.8, and the angle here is 27 degrees. Okay, and then they tell you that this angle is 106 degrees, and each A and B have a magnitude of 13.8, both of them. What we're going to want to find is R, where R is equal to A plus B. And we're going to want to find the components of R and the magnitude of R and the angle it makes with the x-axis. So one way of doing this is we can note that A is here, B is here, and if we draw a vector R from the tail of A to the tip of B, R, since this is the origin, A plus B minus R is equal to 0, or R is equal to A plus B. Right? Okay, we've done that before. However, you need to find, since R is R of X plus R of Y, you need to find Rx and Ry. And Rx is going to be Ax plus Bx. And the components of Ry are going to be Ay plus By. And if we want to make these hats, sure, make them hats. And then this is X hat, and this is Y hat. But we shorthand write it Rx and Ry. Finding the vector A's components, because we know the angle, is pretty easy. A is at 27 degrees, and it has a magnitude of 13.8 meters. So A of X is A cosine of this angle, and A of Y is A sine of this angle. If you put in 13.8 cosine of 27, you get 12.296 meters if you want, and 6.265 meters if you put in 13.8 sine of 27. However, to find B of X and B of Y, we need to find the angle associated with B. And it's not the angle given. It's the angle from the x-axis. We can move, assuming the x-axis is always parallel to the one that we have here. So we need to find the full angle from that x-axis to B. And that is, this angle here is the same as angle 1 plus angle 2. So the angle to B is really angle 1 plus angle 2. And we see that's 27 plus 106, which is 133 degrees. So the components of B are B, which is 13.8, cosine of 133, and B sine of 133. And we can see here that B of X is going to be negative. If we put B at the origin, right? So imagine on a different origin, B would look like this, and it would be at 133 degrees, right? These components, the X component will be negative, the Y component will be positive. The B component in the x direction is negative 9.412. And the b component in the y is 10.09. Everything else on here is easy, okay? All we have to do now is add ax plus bx, and that would be 12.29. So Rx is 12.296 minus 9.412. You just add them. And Ry is 6.265 plus 10.09. These end up being 2.844 and 16.335 is what I get. If we look here, they're close to what these are. They're a little bit off, rounding errors or whatever. So to find the magnitude, all you have to do is find Rx squared plus Ry squared. To find the angle of a triangle, of any triangle, tan of the angle is y over x. So arctan of Ry over Rx will give us the angle. And if you put these numbers in, you'll find that you get 80 degrees. Okay. And if you put these numbers in, you get whatever it is, 16.6 or whatever. So that's not too tough. The only tough thing to remember is that when we find the components of a vector, we want to find them from, let's say, the x-axis. We always have to know when or what axis we're talking about and what we're trying to find. Other than that, I think this problem's not too bad. The reason why I gave it to you was obviously having to figure out that angle, and then a little bit of practice of finding the magnitude of a vector from components and finding an angle from components. So hopefully that wasn't too bad. Hopefully most of you got it. Now, we have two vectors, r and s, and I'm going to draw them, but we're given two vectors, r and s. We're given their magnitude and we're given their angle to the x-axis. And then we're asked to find their dot product and their cross product, specifically the magnitude of the cross product. So we don't, it's going to be a vector, but we don't care that it's a vector. We just want a number from it. You could do this two ways. So you could do this component-wise. R dot S is some components. But since we've been given the magnitudes, the magnitude of R times the magnitude of S times cosine of the angle between R and S is the dot product. And the cross product, similarly, is R S sine of the angle between them. And there's a Z thing here, okay? Normally, but we're only going to get the magnitude, so we only care about this part. We don't care about the whole Z direction or anything like that. So what you can see from here, they gave us the magnitudes and they gave us the angle of each of them, but they didn't give us the angle between them. So we need to draw them. So if I draw this on an XY plane, I see that R, or I'll start with S. S is at an angle of 42 degrees. And if I go all the way around to 314 degrees, I find R. However, I can also go the other way. So 360 minus 314 is 46, right? So this angle is negative 46 degrees down to R. And S has a magnitude of 8.98 and R has a magnitude of 4.33. Now the angle between them, remember the dot product, it doesn't matter, but the cross product, we're going to go R to S. We just need the total angle, forget about the negative sign. So an angle from the vector R to S would be 88 degrees. So this is the angle RS is 88. And from there, this is simple. Because all we have to do to find R dot S is 4.33 times 8.98 times cosine of 88. And if we do that, we'll get this. And R cross S is 4.33 times 8.98 times sine of 88. And we'll get that. Note that when we say R cross S, what we mean is we take the vector R and we turn it, we rotate it to S. If you let your fingers do that rotation, like hold your hand up in front of you and rotate your fingers of your right hand in the direction of R to S, like imagine your fingers are pushing R to S, you'll see that you're rotating counterclockwise. Or what we say is that you're rotating along a Z axis that points out of the page. This is a clockwise or a counterclockwise rotation. This is positive, because if this is an X axis, this is our normal way of rotating through angles positively. If we were trying to turn S to R, if we were doing S across R, it would be along a negative Z axis. Your thumb would point into the screen so that your finger could push S down to R. Your thumb would be pointing into the screen. The rotation would be clockwise. It would be a negative rotation. We don't care about that in this problem, but when you do right-hand rule, that's what you're doing. So this isn't too bad. You had to be able to figure out what the angle between them was. One last note is you don't cross R to S the long way. So you always take the shortest angle. This would be, what's 360 minus 88? 252? No, I'm sorry. 272 would give you this angle from R to S is minus 272, but you don't ever take the angle that's bigger than 180. Always go the short way when you're crossing or dotting. Put them tail to tail and measure the angle between them along the shortest change of angle. Okay. Our last one is, I wanted you to do a little bit of vector product algebra, I guess you would call it. So note we have to do this first. I should also say that whenever you cross A and B, yeah, you can do the magnitudes, but you also have the components. And I'm sorry I messed this up in the lecture video. If you ever want to remember it, you can remember it as I, J, K, or X, Y, Z, AX, AY, BX, BY, BZ. I'm sorry, I'm being so dumb. Messing this up too. AX, AY, AZ, BX, BY, BZ. Okay. The determinant of a matrix, or what this is for the I component, what you do is you cover up this column and you do a cross product on these four, meaning AY times BZ minus BY AZ. So AY BZ minus BY AZ. And you do that for each column. So when you do this column, you do BXAZ, AXBZ. There's a small wrinkle here that every other column gets a negative sign. You'll learn that if you ever do vector analysis or differentials, or you may even learn that in calculus 3 or something. I'm not sure. Sorry, I'm answering a question for someone. So when you do this, you get, for the J or Y components, you get A, Z, BX minus BZ, AX in the J hat. Okay. And then finally, for the K, you get AX, BY minus BX, AY. Let's double check that I've done that right. X, YZ, YZ, Y, X, YZ, XZ, XZ, and XY, XY. Okay, so this is how you find the cross product. If we want to multiply this by a constant, we can do it after we do this. This 3 in front of the A, it's the same thing as multiplying the answer by 3. Okay, let's do this really fast and find it. AYBZ is 3 times 3, so this is 9. and I'm going to multiply the whole thing by 3. 9 BYAZ is 2 times, so minus 4. That's a 13 in the I hat direction, plus AZ BX, which is minus 2 times a minus 3. So that's 6 minus BZ AX, which is 12 in the J hat. Sorry, I didn't want to do that. And then finally, AXBY is 8 minus BXAY, which is minus a minus 9. And that's in the K hat direction. And I'm going to multiply that by 3. So 3 times 13 I hat minus 6 J hat plus 17 K hat. And what this ends up being is 39 in the I hat minus 18 in the J hat plus 51 in the K hat. And that is this. Now, again, if we want to dot this with 2, so 2 dot C would be 12 I hat minus 16 J hat. And when you dot product something, any two vectors, A dot B, is AX BX plus AY BY plus AZ BZ. And the answer is a scalar, so you won't have any of these unit vectors. That's because what we're really going to do when we do this 2C dotted with 3A cross B, we're actually going to be doing 12 I hat times 39 I hat. The I hats, when you multiply them, because they're both the same, you get a 1 and they go away. That's the formal vector analysis way to do it. Minus 16 times minus 18. And this is J and this is J. And then finally, 0, C doesn't have a Z component, 51K. So this goes away. And so what do I get here? I get, when I do this in my calculator, 12 times 39 is 468. And 16 times 18 is 288. If I add those two numbers together, I get, no surprise, 756, which is our answer right here. Okay, so yeah. And then also remember that you couldn't do this as 2C dotted with 3A and then cross that. You could not do this crossed with B, because this ends up being a scalar and you can't cross a scalar and a vector. This makes no sense. So oftentimes they'll drop the parentheses. You could pull the whole, you could multiply 3 and 2 in the front. So this could be 6C dotted with A cross B, and that's fine. But that's something you'll learn in vector analysis or whatever. We probably won't use it. But just know that those are the rules. I wanted you to practice cross products a little bit and practice performing cross and dot products. It's important for you to know how to do. You don't really need to know how to do it for the test if you're a little shaky on it. Don't worry too much about it. So now we're moving on to all the homework 2 problems. And homework 2 problems are all constant acceleration or free fall. Because free fall is constant acceleration in 1 dimension. It's also projectile motion in 1 dimension, but we're not supposed to know about projectile motion yet when we do this homework. So this particular problem, you're trying to figure out, you have 3 phases. You're going on a job interview and you have 3 phases. You have part 1, part 2, and part 3. And then you have the total. So when we read this problem, we know we have to travel 300 kilometers. And we're going to do it, if we have to be there at 11:15, we're leaving at 8. So we're going to do it in 3 hours and 15 minutes, which is 3.25 hours. Not 3.15, it's 3 1/4 hours. 15 minutes is a quarter. So we have 3 1/4 hours to do 300 kilometers. And we're going to drive at a different velocity in part 1 and part 2 and part 3. we're going to travel a different distance. So what we're going to do is we're going to write this up as x1, t1, and v1, and x2 and v2 and t2, and x3 and v3 and t3. And we're going to figure out what these are from these two and the total time. So we'll do that each part. The only equation we have is we have x final minus x initial is equal to b times t for each of these. But we're really going to write this as our change of x is equal to b of t. And we're just going to call x1 the change of x for 1, and x2 is the change of x for 2, and x3 is the change of x for 3. We're not being particularly careful, but that's okay. And here we see the time is the change of x over v, or I'm just going to write it as x over v. How far we traveled over the velocity. That's because we're assuming that you're traveling at constant velocity in each region. Not the same velocity for each region, but constant velocity as you go through each region. So our goal here is going to be to figure out what each of these values are. It tells us that for the first, or for the whole trip, we plan to drive 100 kilometers. We drive 100 kilometers for the first part. So we drive 100 kilometers an hour, I'm sorry. And the first part, we go a distance of 110 kilometers. So what is the time? Well, T1 is equal to X1 over V1, and that's 110 over 100 kilometers per hour. And you can do this without a calculator, 1.1 hours. So for 1.1 hours, we drive at 100 kilometers per hour, and we go a total distance of 110 kilometers. In the second part, there's construction work, and it forces us to slow down to 44 kilometers per hour. And we do that for 44 kilometers. So we need to know how long we do that for. T2 is X2 over V2. This one's super easy because it's 44 over 44. And so this ends up being 1 hour. So this part of the trip takes 1 hour. And then it asks, how fast would we need to go in the third part to get there on time? And so for the third part, we should note that the total x is equal to x1 plus x2 plus x3. And the total time is equal to time 1 plus time 2 plus time 3. And we want to find V3 is x3 over T3. So solve this for x3. x3 is x total minus x1 minus x2. Well, we knew we were going to go 300 kilometers. In part 1, we went 110, and in part 2, we went 44. Therefore, how many kilometers do we have left? We have to go 146, right? 146 plus 44 is 190, plus another 110 is 300. So in X3, we need to travel 146 kilometers. That's how far we have left in part 3 to get there. Now time 3 is the total time minus time 1 minus time 2. And this was 3.25 hours. Time 1 took us 1.1 hours, and time 2 took us 1 hour. So the time we have left is 3.25 minus 2.1, and that's 1.15 hours. So if we plug these things in, we get 146 over 1.15 km per hour, and if I do that on my calculator, I get 146 divided by 1.15, I get 126.96 km per hour. And that's my answer. That's the answer they got. So I'm sure going outside, there are people outside. I'm sure that you could probably do this without all this formal math, or you could do it some other way. But This would be a formal way of accurately determining how long the last part of your trip would take. As I said, there's probably other ways to solve this. I'm probably doing this the long way. It's how my brain works. But yeah, that's the solution if you need it. That's how we do it. All right, so for 2.15, this problem, you're given a position equation. This problem, I think, causes the most headaches for students. I really don't like part of this problem, and I should probably take it out because I don't like how it's worded. But I wanted you to have practice taking a derivative of a position function to find the velocity, and at least understanding that's what we're doing, and how to do it, and how to find the velocity from the derivative. So we have this position function. X is equal to 11 plus, well, minus 12t plus 3t squared. And we're asked to find the velocity at t is equal to 1 second. How we do that is we take the derivative. The velocity is the derivative of x with respect to time. And we then plug in for t 1 second. So let's do this. The derivative of a constant is 0. The derivative of a single power, the power goes away, and we get minus 12. The derivative of a power comes down, you lose 1 in the power, so this would be plus 6t. Multiply by 2, drop the power by 1. So this is our velocity. Our velocity at a time of t is equal to 1 second would be minus 12 plus 6 times 1, or minus 6 meters per second. Note that when time is 0, okay, when our time is 0, we have a minus 12 meters per second. We're going to need that later. So this is actually the answer to part A. They say, what is the velocity at t is equal to negative, or t is equal to 1? That negative sign tells you that the particle is moving in the negative direction. So question part B is kind of redundant. You already know that. Part C gets a little weird. And it's why we don't use speed. Speed is just the magnitude of the velocity. The magnitude of minus 6 is 6, right? So the magnitude of v is the absolute value of negative 6, which is 6 meters per second. And this is the part that bothers everyone. It bothers me. Is the speed, we're talking about the speed, increasing or decreasing just then? Well, at v of time equal to 0, it was minus 12, or taking the absolute value to get the speed, it was 12. At time t equals 1, it was 6. So the speed decreased in magnitude, but the velocity was increasing in a positive direction. So really, I think it's more important to know that it's increasingly positive, but we note that how fast you're going is actually decreasing until you stop and turn around. Which leads us into part E. Is there an instant when the velocity is 0? Can this equation equal 0? Well, sure. If time is 2, we get minus 12 plus 6 times 2. This is 0. So at time of 2 seconds, this is 0. Is there any other time? No. The only time this thing can be 0 is if t is equal to 2. For part F, is there a time after t equals 3 seconds when the particle is moving in the negative direction? Well, basically, after t is equal to 2, t greater than 2 seconds, this value is going to be positive. So there's no time after t is equal to 2, actually, when this particle is ever moving in a negative direction. Those are just understanding what the velocity is telling you, and thinking through what this velocity actually does, analyzing what the motion does. You could graph that function if you wanted to. I don't know what it would look like. Starting from time 0, it would be negative 12, and then it would reduce to 0 at 2 seconds, and then it would be increasingly positive. So this thing would be heading like this way, slow down, turn around, and come back and head the other way, which is fine. Not important for this question. All right. This problem is a constant acceleration problem. In this problem, we have a vehicle that starts from rest, accelerates until it reaches a maximum velocity. As soon as it hits that, it decelerates and stops. And we want to know how much time is there total for both of those, acceleration and deceleration, and how far does it go in that time. So in this problem, there's two distinct parts. Part 1, A, is 1.8 meters per second. You're accelerating. In part 2, A is negative. You're decelerating, okay? And so we're speeding up until we hit V final, and then we're slowing down, so we stop. So we start at rest, we hit this V final, which is 25 meters per second, and then we decelerate and come to a stop. So we're going to need to solve this as two different parts. And in the first part, what we always do is we always write our variables. We are going to have acceleration. This is the problem once you start doing projectile motion, is you want to put negatives in and weird stuff in. We're just doing straight line motion, so our equations are, for instance, v naught t plus a t squared over 2 and final squared minus v initial squared is 2a x final minus x initial. No negative sign on the a. That's only negative when we do g because we assume that y is positive up. So for the first part, the only part I care about is this part with this acceleration of 1.8. I know I start from 0. I start at x is equal to 0. I don't know what x final is. I'm going to call this x final 1, and this is x initial 2. They're the same value. This will be time 1, and this will be time 2, and we'll add the time to get the total time. But we'll figure out the time for each part by itself. Okay, so I know this was 0 because it started from rest. I know v final is 25 meters per second. I don't know what t is. I don't know what x final is. I want to find both of those. So looking at this, I have everything here. In fact, so since that's 0, I get v final squared is 2a x final minus x initial, but x initial is also 0. So I can find x final as v final squared over 2a is 25 squared over, let's just write that, 25 squared over 2 times 1.8. So 25 times 25 divided by 3.6 is 173.6 meters. So at this point, we're at 173.6 meters. The time is easy to find because v final is equal to v initial plus at. V initial was 0, so t is v final divided by a, which is 25 divided by 1.8, which is 13.9 seconds, let's say. Close enough. So now that we have this, here's the trickier part. We need to do part 2. And we reset our variables for part 2. I could put little 2 subscripts on this. I'm not going to. I'm just going to write what they are and tell you what they are. Part of the reason why I wanted to do this as a video. So x initial for part 2 is actually x final for part 1. And x final here is x final for the whole motion. Whatever this value is the total distance from starting to stopping. V initial is v final of part 1. So this is part 2, sorry, which was 25 meters per second, but it comes to a stop, so 0. A is minus, we're decelerating by 1.4 meters per second squared. I don't know what T2 is. I'm going to put a subscript on that. Because once I find T2, I'm going to add T1 and T2 together. And T1 is 13.9 seconds. T2 I don't know, but when I get to total from adding T1 plus T2. All right, so I can again just repeat what I did here. So X final, except that I shouldn't say that actually. So X final for part 2 is V naught T minus GT squared over 2. I don't want to use this because I don't know X final or T. So what I want to use is V final squared minus V initial squared is 2A times X final minus X initial. And remember, this isn't 0 now. This one is. So what I get, and I'm trying to find X final, I get minus V initial squared over 2A is equal to X final minus X initial, or X final is minus V naught squared over 2A plus X initial. Remember that A is negative, it's 1.4. So this is negative 25 squared over 2 times 1.4 with a negative sign, so those will cancel, plus 173.6. And what I get is I get 25 squared, 25 times 25 divided by 2.8, and that's 223, plus 176, 173.6, is 396.8. Let's hope this is correct. 396.8. Now I can find the time here, and how I find the time is I know V final is equal to V initial plus AT, again 0. So V initial is equal to minus AT, or T is equal to V initial over minus A. V initial was 25 for the second part, minus a minus 1.4. So I get 25 divided by 1.4, or 17.86 seconds. If I go back to here, if this is 17.86 seconds, to get the total time, I just add those two numbers. So plus 13.9, I get 31.75. My number's a little bit off from rounding. Sorry, I'm dyslexic apparently. 31.75 seconds is what I get. So the key idea here is that you can divide this problem up into individual problems. Secondary idea is how we do these problems is we draw a picture and we write down variables. That's what I want to see on an exam and on a quiz. You writing down your variables, you drawing a picture. The third thing on this, what makes this problem a little harder than an average easy problem, is that when you get to part 2, you have to use your final variables from part 1 as your initial variables for part 2. As with everything, there's probably a way to do this without breaking it into 2 parts. I find that breaking it into 2 parts makes the most sense logically for me. It's kind of my logic. But you may find a way to do this faster without breaking it apart. That's okay. If you want to do it that way, it's fine. As long as you get the same answers, we're good. Okay. Hopefully that problem wasn't too bad and it taught you something. We're now in Freefall. One of the things I wanted to talk about with this problem is one of the things that makes things really hard in physics is you are not always told things. You have to assume things. And this problem, you have to assume some things. So we have a raindrop that's going to fall, and we're told it's going to fall a distance of 10, 20 meters. 1.02 times 10 to the third, move the decimal over 3 places. It's not slowed by air resistance. And we need to figure out how fast it's going to be moving when it hits the ground. So redrawing this with our variables labeled. Y initial at the top is either 10, 20 meters, and this is 0 when it hits the ground, Or you could say this is 0 at the top and this is negative 10, 20. You could start measuring up there, it doesn't matter. The assumption comes in where we're going to assume it starts from rest. They didn't tell us that. They just said it was up in the cloud and it drops. I'm going to assume that it drops from rest. Write my variables. The initial would be final, A and T. Remember that A is G and it's downward, which means this is minus 9.81 meters per second, or 9.8 if you want to use that in Wiley. This was 1020, this was 0, the initial was 0, and I need to find V final. I don't have time. The only thing I have without time is this equation with a minus G, Y final minus Y initial. My initial velocity was 0. My final time is 0. Those negative signs cancel each other. So I get V final squared is 2G Y naught. And V final is 2G Y naught. Square root. Square roots can be positive or negative. Do we take the positive or the negative? We take the negative because we know it's falling down from the picture. The square root of 2 times 9.81 times 1020 is 141.46 for me. I think why I got such a big number is if I take 2 times 9.8 times 1020, I get 141.393. So they're using, in Wiley Plus, they're using 9.8 meters per second squared for G. So if you do that, you get 141.393 meters per second. It is negative. I don't know why. I guess because all they said here was how fast would it be going. So keep that in mind. This problem did not tell you that it started from rest. And this problem in Wiley Plus is taking a positive velocity, even though we know that it's falling straight down. Because Wiley has decided that Y is positive down, that this is acting like constant acceleration toward the ground. And that's totally okay. If we do that, this would be a positive here, right? And what we get is we would still get this negative here. That's a small problem, right? What are we supposed to do with that negative sign? So do it this way. I don't know why Wiley Plus. I guess they're taking the magnitude of the velocity towards the ground, or they're being nice, or they're just not being very careful. But overall, the things to learn from this is, when in doubt, assume it starts from rest. Draw a picture so that you know what's going on for yourself. Draw a picture and label your variables and label your acceleration. And then just list your variables. From this, you can easily see, okay, I need V final. I don't have time. I use the equation without time. Of the 4, I go straight to the one without time. That's it. It's a pretty simple algorithm for solving these problems. Hopefully it's not too hard. All right, we have 3 more to go. So a hoodlum, meaning I don't know, a criminal, throws a stone from above the ground at the ground. I don't know why it's a hoodlum. So here what we have is we're throwing a stone towards the ground. Y initial, I'm going to say, is 44 meters. Y final, when it hits the ground, will be 0. It's originally thrown with an initial velocity downward of 17 meters per second. Remember that A is G and also downward. And so what we want to know is how long does it take to hit the ground and what is the speed? In this particular problem, I gave you this problem because if we look at this really fast, A and T, this was 44 meters, 0. This was minus 17. Don't forget the minus sign. and this was minus 9.81 meters per second squared. So now looking at this, they asked us for the time. How long, meaning how many seconds does it take to hit the ground? If we look at our equation with time, y final minus y initial is equal to v naught t minus g t squared over 2. You can solve this for time, but it's going to be a quadratic. I hate quadratics. I tend to mess quadratics up. It's just a few more steps in a quadratic that I don't want to do. I could instead solve part B first and go back and get the time, and that's what I'm going to do. I know that v final squared minus v initial squared is equal to minus 2g y final minus y initial. This is 0, okay? This is not 0. So I get v final squared is equal to v initial squared plus 2g y naught. And if I take the square root of both sides, and I need to remember that v final is going to be negative because it's down, I get that v final is negative of this. V initial was 17, so square root of 17 times 17 plus 2 times 9.8 times 44. I get 33.93, which is exactly what they have there. Again, they're just listing the speed. The speed is the magnitude. So they're just asking for the magnitude of the final velocity, no sign. Once I know that, though, I know I have v final minus v initial is equal to minus gt, or t is equal to v final minus v initial over minus g. Now v final was minus 33.93, v initial was a minus 17, and this is a minus 9.81. So what I get is I get 33.93 plus 17 divided by 9.81. And I get 33.93 with a negative sign. So negative 33.93 plus 17 is negative 16.93 divided by negative 9.81. And I get 1.726, so 1.73, which is what they got. Be careful here with your signs. As you can see, I messed up my signs and I got something weird like 5 seconds. There's no way that something's going to fall 44 meters starting at a velocity of 17 meters per second, being accelerated by gravity, then it's going to take longer than 2 seconds, right? It's covering 17 meters per second if it wasn't being accelerated, and that's a little bit over 2 seconds. It's being accelerated by almost 10 meters per second squared. Yeah, it's going to take less than 2 seconds to get to the ground. Just know that from math. Understand that it's about 3 meters. It's about 30 feet per second, right? Because a meter's about 3 feet. So it should cover about 15 feet in the first second, and then about 40 feet in the second. Just being accelerated by gravity, which is kind of worth noting how fast things fall. All right, we're moving on to 2.49. This problem I gave you because there's a very, very important step here that you need to understand. We have a balloon, and this balloon is rising. A hot air balloon is attached, uses hot gas. Someone's going to throw an object, well, hold an object out and let it go. But at the time that they release it, this thing is going up with a velocity of 13 meters per second, which means everything attached to it is going up, which means the initial velocity of the package is up. It goes up, or it begins with a positive upward velocity. If you start this package at rest, you'll get this answer wrong. So we know how high we are above the ground. We write y initial is 88 meters. Y final is when it hits the ground. V initial is upward 13 meters per second. and A is down, and is G. And that's all we have. And we want to know how long will it take to hit the ground and what speed does it hit. So Y initial, Y final. This time I will do the quadratic for the time, just for the heck of it. So this is 88, this is 0, this is 13. We don't know what V final is. This is minus 9.81 meters per second, and we don't know the time. So as I said, if we want to find the time, we note that this is a quadratic. Y final is 0, so what we really have is we have minus gt squared, or 0 is equal to minus gt squared over 2, plus v naught t minus y final minus y initial, which that goes away, and this is 88. So our A term is minus g over 2. Our B term is v naught, and our C term is y initial. This is 88. This is 13. This is minus 4.9. Plugging that into minus b plus minus b squared minus 4ac over 2a. And these two things will give me time because that's what the quadratic is. This is negative 13 plus or minus 13 squared minus 4 times minus 4.9 times 88. All over 2 times negative g, which is negative g, or negative 9.81, if you want to put that in there. So if I do this, the square root of 13 times 13, a minus and a minus give me a plus, so plus 4 times 4.9 times 88. I get that this is minus 13 plus or minus the square root of all that gives me 43.52, and this is over minus 9.81, or 9.8. Now, I need time to be positive. Therefore, I need to take the negative of these. If I took the positive, I get a positive number divided by a negative. I don't want to do that. So use the negative. So negative 13 minus 43.52 is 56.52 with a negative sign, divided by 9.8 is 5.767 seconds, which is exactly what they got, right? It's what they got right here. So you could have solved for the final velocity first using what we did last time. V final squared minus V initial squared is minus 2g, Y final minus Y initial. And then solve for time using what we're going to use right here. Or you could plug in the time here. We know this is 13 minus 9.8, and this is 5.767, and that'll give us the final velocity. So 13 minus 9.8 times 5.767 is minus 43.5 meters per second. Again, Wiley Plus is asking for the speed or magnitude without a sign of the final velocity. But our final velocity, we know, will be negative because we chose y to be positive upward in this problem. Right, cool, we're all good. Yeah, so this problem and the problem before it are kind of twins. This problem, you have an initial velocity down. This problem, you may not realize that you have an initial velocity up. You definitely do. All right, so our final problem is really an introduction to projectile motion in a weird way, because we do the same things we do in projectile motions in this problem. In this problem, we have a car that starts from rest, so a car. So V initial of the car is 0, and it has an acceleration of 1.7 meters per second squared. Right when it takes off, it gets passed by a truck that has constant V. That means A of the truck is 0. V of the truck we're given as 9.7 meters per second. And we want to know how far will they travel before they catch each other. So I'm going to do this in X. X initial is 0, x initial is 0 for both of them. X final will be the same for both, and time will be the same for both. So what we do in this problem is for the car and for the truck, we write their equations or their variables. V of the car, V final, V initial of the car, and V final of the car. A of the car and T, and X initial, X final, V of the truck. I'm not going to write V final because A of the truck is 0. So V of the truck is always the same. I know it's 9.7 meters per second. X initial was 0. I don't know what X final is, but this is what I want. And then I'm going to find time as well. No, I'm not going to find time. I'm going to find the final velocity of the car. X initial of the car is 0. X final, I don't know. I want that. V of the car from start is 0. It started at rest. V final, I don't know. A of the car is 1.7 meters per second squared. And T, I don't know. So you can think of doing this one of two ways. But I'm going to do it the first way. I know the equation of motion for the truck is X final minus X initial is V of the truck times T. Solve this for T and note that that's 0. So X final over V of the truck is T. And then you can plug this T in for on the car, X final minus X initial is equal to V naught of the car times T plus A of the car, T squared over 2. This is 0. This is 0. So X final is equal to A of the car over 2 times T squared, but T is X final squared over VT squared. If I multiply through by VT, divide by X final, I see that I get X final is VT squared over times 2 over A of the car. That is 2 times 9.7 squared. 2 times 9.7 times 9.7 divided by the acceleration of the car, 1.7, and I get 110.7 meters. That is how far they went, and we're good. Now I can find the time by V final is equal to, no, I can find the time using the car equation, that X final minus X initial was V naught of the car times T plus A of the car T squared over 2. I know what all this is now, and if I plug that in, I can find time. But I'm not asked for time. I'm asked for V final of the car. And V final of the car is V final squared minus V initial squared is equal to 2A of the car times X final minus X initial. Solving this for V final because it starts from rest, V final is, and this was 0, square root of 2A of the car times X final, and that would be square root of 2 times, what was A of the car? 1.7, and that was 110.7, and I get 19.4 meters per second, which is the answer they got. So the trick in this problem that I wanted to introduce you to was that you could substitute the equations for the car into the equations for the truck, or vice versa. And the truck equations are only X final minus X initial is equal to V naught T, and V final is equal to V initial. Because there's no acceleration, that's exactly the same as projectile motion in the X. The car is accelerating. So if the car could have some initial velocity, it doesn't matter. What we do is we still substitute time in for the truck. We may have to do a quadratic, but you know, that's the price we pay. So that's it. This is the homework. You have till tomorrow night to get it done. Hopefully I've answered any questions you weren't able to ask or weren't comfortable asking or couldn't find help, or maybe just didn't quite understand. I'll do this again for homework 2 and homework 3 on Sunday. I'll get them to you. I'll try to get them to you Sunday morning so that you can study for the exam if you need the help. if you don't have homework 2 and 3 done, at least try the question before I go through the solutions with you. But I want to make sure you have solutions and you understand why we do certain things. Okay, anyway, I hope this is helpful. If not, well, you don't have to watch it. Anyway, I'll talk to you guys tomorrow.